Good afternoon, all.
Afternoon, sir.
Afternoon, sir.
Evening, sir.
Hey, JJ, what's up?
First year today, sir.
No, sir. You can't first me today. Me sit down and watch you come in and me say, hey, brought you, catch you before you.
Is it for me, sir?
Yeah, man. I mean, I say good afternoon, long time too.
All right, sir.
All right, then cool. Soon come.
Good day, everyone. Good day, sir.
Hey, man, easy, easy, easy.
Evening.
All right, so that's all the time I'm going to give you to get in for this evening.
Sir,
Yes, please.
I just reach home. I don't want to show you. Can't wait to come.
No, man. One go hurry and come, man. One go take a quick wash off and come. I won't
Alright.
catch fire. Cool. Um, yeah, I really hope that you guys are well. And I was expecting more students to be here though. With my business class students, I was expecting about twice as much as I but let's see. All right, so we've gotten to yet another end of the week. And getting closer and closer to our exams. Tonight I'm moving into something new. As promised, on Wednesday in class, Calculus 1, we spent quite a bit of time doing just 2 piecewise function questions. And
Sir, I mean for cut yes. Sir, today you say I give you the questions, sir.
I know,
Okay.
but I know what I said and I know the promise, but plans may have changed somewhat because of what I need to cover. Plan was on Wednesday of this week, when we had class, I was supposed to teach you all the introduction to differentiation so that come today, we could move directly into more stationary points. But because we took so much time, not that I'm complaining, because at least I know somebody had a better understanding to the piecewise, it set us back somewhat. So I want to use the first session. I call this up until I gave you 20 minutes out of it to get into class. So we're going to use the next 40 minutes to talk about some differentiation, the rules of differentiation. The truth is, I started this with the business calculus on Tuesday, Thursday morning of this week. Not everybody caught on to it, but for the most part, most students, business calculus students are okay. So it's still a learning process for everybody. Those of you who catch on, you have an opportunity to solidify it. And those who have not caught on, you have yet another chance. And for the Calculus 1 students, I'm going to ask that you come close, because you must catch this at the 6 o'clock hour, so we can spend some time going through our piecewise function. If you don't catch it in the first, up to 6 o'clock, it means that I have to go use the second third of the class and just spend that hour on differentiation. But for sure, by the last third, we must begin our stationary point. So calculus 1, technically we're going to be doing two areas tonight. Business calculus, we're going to be looking at one area. Now, there are many rules to differentiation. Many rules to differentiation. You have the chain rule, you have the product rule, you have the quotient rule, you have the power rule, you have rules talking about the trigonometric ratio, how to differentiate using sine, cosine, tangent. have so many rules. The logarithmic function, the exponential function, so many rules. Sir, do we have to know them? Yes, everything outside of the trigonometric functions, sine, cosine, and tangent. So the logarithmic rule, you will learn it. The exponential rule, you will learn it. But for sure, the 4 basic rules, you'll also learn those. Let's say, no love mark up and teach us make a charge no lunch money. Charge on the lunch money. All right, let's go.
Sir,
Yes, please.
sir, remember, you have to disable us first.
That's what I'm saying, and I keep forgetting. So, like, seriously, I'm really happy that you guys are here, and they promised us. Well, it was said that we're gonna have thunderstorm-like rains today. The sky just kind of look a little awkward, but thankful that there is none. So this is going to be calculus 1 on October 10, 2025. And we're going to be talking about differentiation. Watch me. Guys, I promise you, this is not difficult. It's not difficult. Y is equals to x to the n. Y is equals x to the n. dy by dx is going to be equals to n x to the n minus 1. Y is equals to x to the n. Y is equals to x to the n. dy by dx is equals to n x to the n minus 1. Okay, sir, I'm seeing that, but I have absolutely no clue what it means. Well, thank you for your honesty. So the function here is y. The function is y. And the function y is in x. The function y is in x. And I can say to you that my independent variable will be x. And my dependent variable here is y. And the x is raised to a power n. Now to find dy by dx, the rate of change of y with respect to x, we're looking at the rate of change of this y with respect to this x. So dy by dx, watch me, is going to use this n, and you're multiplying it by the coefficient of this x. The coefficient of this x is 1 in this case. N times 1 is this n. Chair. I'm here the whole day today. Is that n? All right? And then we are going to write back the variable x. But we're going to be reducing it by 1. We're going to be reducing it by 1. So that's why I have n to the minus 1. So will we do this all the time? Absolutely. 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 All right? So y is equals to x to the n, dy by dx is going to be equals to nx to the n minus 1. this n times the coefficient in front of that, and then I write back the variable, that's the same. I write back this, but I'm reducing this by 1, minus 1 power. And that's what my dy by dx is. Sir, I see what you're talking about, but I don't think I catch on to it yet. Can you do an example or two? Not a problem. So if you're given y equals
Sorry, sir, hold on a minute. In the function, you say y is the function and x is an independent variable. Did you say y is a dependent or variable? That's why you said, or it's an independent variable as well.
no man, y has to be the dependent variables. Y is
Okay,
dependent upon
I
x.
just
Right.
wanted to.
Yeah, man. So x is the independent variable, and y depends on x. So when this moves, this has to move. So this is the boss, and this is the boss playground. So what x is going to be the independent variable, and y depends on x. All right? Okay.
Excuse me, sir. Is the d in the dy dx representing the differentiation?
No, dy by dx is representing the differentiation.
Oh, okay.
Right. Right. So let me give you something first before I do that. If I give the function, in y, then when we differentiate, that's differential. Oh. D-I-F-F-E-R-E-N-T-I-A. Sure, come on, a pen, man. Sure. So if I give a function in y, the differential is going to be given by dy by dx. If I give it a function in, say, p, and of course the function is going to be, with respect to p, with respect, this is going to be p dash of x. If I give you r, it's going to be r dash of x. If I give you as m, it's going to be m dash of x, right? But if I give you as y, it's not going to be y dash of x, even though sometimes you see they put it as y dash of x, the notation. But really and truly, when it is that we use y, we normally use it as dy by dx. It's just a representation of finding the rate of change of y with respect to x. With respect to x. Those of you who are taught foundation concept 3.2, we would have been introduced to this some time ago, but not necessarily this notation. It would have been the notation when it is that we're sketching the graph in the completing the squared form. All right. So if I'm finding, that's the first derivative. If I'm finding the second derivative, I can call it second derivative or the second differentiation, and I give you y of x. The first derivative is going to be dy by dx. The second derivative is going to be d squared y by dx squared. Okay, you're having internet challenges? Kino? Kino?
Yes, sir, I'm having internet challenges.
Oh, I see you leave. And my Crosswell, you're having challenges too? All right, Crosswell, good on boss. All right. And if I'm finding the third derivative,
No.
it's going
Yeah. I just got you know.
okay.
I had to rejoin because I couldn't see the whiteboard.
Okay, got you. So the third derivative is going to be d cube y by dx cube. I'm just showing you how it is that we get the stuff. Now, if I'm using p of x, as I told you before, it will be p dash of x. The second derivative is going to be given by p double dash of x. The third derivative will be p, sure, triple dash of x. If I give you r of x, r dash of x, r double dash of x, r triple dash of x. If I give you m of x, m dash of x, m double dash of x, m triple dash of x. Are you getting the gist of it now, guys?
Yes.
All right, good. So now, I'm differentiating that. I'm going to take you from, incidentally, I skip first principles. I will go back to it. Yes, both groups need first principles. I need to teach both groups first principles. But because I must start stationary point tonight, I have to jump over and teach you this topic first. So I'm going to be differentiating. No, I'm going to put some stuff here. And it's only for teaching purposes. So only for teaching purposes, I'm going to put some stuff. What power is this x raised to? Is this x raised to a power?
Sir,
It's
I'm not seeing where
So where
your
is
cursor
your
is. Your cursor. 1. It's raised to 1.
you're correct. Oh, come on. So this x is raised to the first power. It's raised to the first power. All right? Now, let me recall something for you. A to the first power is simply equals to A. A to the first power is simply equals to A. Now, I'm putting my first power there. I'm going to differentiate now. Dy by dx is going to be equals to, this one is going to be used to multiply the coefficient of x. So 4 times 1 is 4. I'm going to write out the variable, and I'm going to subtract 1 from the power. When I subtract 1 from 1, what do I get?
0.
Sir, wait, go back over that again once more where you have the dy by dx.
So I'm differentiating, so I have dy by dx. I have dy by dx.
Oh, hold on, sir. So with y here, we're using the differential for y to solve that, which would be dy by dx.
Right, so I'm differentiating this variable with respect to this x. So the function is in x. So I'm
Yeah.
using this to differentiate with respect to everything that is inside here. So that's why I have dy by dx.
Okay.
All right, good job. So remember the power?
Excuse me, sir.
Go right ahead.
Why would you put back the x right there? So because 1 minus 1, I see you, all right, but the x wouldn't disappear.
You're saying that the x would disappear or wouldn't?
Yeah, why would you write back the x?
Oh, because I was showing you what happens. Why would the X disappear though? Let me see.
Sir, I remember, I just had to read all you did show me.
But you have to remember why message I disappear. Tell me why it will disappear.
Because a zero remaining.
Okay. What do you know about anything raised to the power 0?
Anything.
Yes. You have 20 minutes, sir. No, you not. I forgot. By the time you go up and come back, it's
She done did. Act very strong. Anything raised to the power 0 is 1. So also recall for me, a to the 0 is equals to 1. So I'm showing you that we're still subtracting 1 from the power. So I can't not do that step. So I have to do that step. And then now, I am going to show you something new. That anything raised to the power 0 is 1. That when I differentiate a constant, it's going to be equals to 0. Sir, I don't understand that when you differentiate a constant. Can you show me? Oh, thank you for asking. I'm more than willing to show you. So that 5 is the same thing as 5x to the 0. Let me know if you agree with me.
Agreed.
Yeah, because remember, x to the 0 is 1. And 1 times 5 is 5. It's just that we don't write the x to the 0 because we already know it's 1. So if we are using the law, that says this power is going to multiply by the coefficient of x. It means that I have to use this 0 to multiply that 5 and then reduce that power by 1. But what is 0 times 5?
0, sir.
0. I think I've had it with this pen.
Hold
Jason.
on, sir. Why 5x raised to 0 is equal to 0 times 5?
I'm differentiating.
I guess I blinked.
You blinked, yeah. We're differentiating. Remember we said that we're differentiating. Let me go back again. When we're differentiating, this power is going to be used to multiply by the coefficient of x. So it now becomes n times 1 is this
yeah.
n. And then I reduce the power by 1. And this rule is always the case. It's always the case. So now that I'm here, what is 0 times 5?
0.
Is 0. And even if I reduce this power by 1 to give me x to the negative 1, 0 times x to the negative 1 is still 0.
Yeah.
So that's why the differential of a constant is 0 every single time.
Sir, pause. Let
Go
me
ahead.
just process all of that. Oh. I'm trying.
Sir, while Maya process that, you mind
Yeah.
repeating, sir, from 1
Right.
equal?
Yes. Just one more time from the top.
I have no
Sir,
problem.
let's start over. Let's start.
All right. So I want you all to. All right. So tonight is not a night when you're going to multitask. And if you have to multitask because you're still at work, I'm going to beg you maybe about 10 minutes. Just give me 10 minutes non-stop. Give the baby the bottle, make the baby put the bottle in the baby mouth, or give the baby something to entertain the baby. But use one eye and watch the baby, but the other eye, may I beg you it. If you're driving, listen. And you're undivided. Once you see this once and get it, you're good to go. I'm saying to you from the beginning, I'm saying to you, you're given a function, y equals x raised to the nth power. You're given that function. And you're asked to calculate or to find the differential of the function. And you will see the applications of differentiation pretty soon. So you're asked to differentiate the function. In order to differentiate the function, what you're doing is finding the rate of change of this y with respect to x. How does y change with respect to x? Let me show you what it is that you have been doing this all your life, but you really never know. And teachers sometimes, tell a little white lie, and it's going to keep us away from God. y2 minus y1 over x2 minus x1 equals m the gradient, the slope, and I can now call it dy by dx. That's the rise over the run. That's what that is equals to. y2 minus y1 over x2 minus x1. This is when you calculate the gradient, When you're doing CXC maths and calculating the gradient, you can find the rise over the run. y2 minus y1 over x2 minus x1. Yeah, man. That is equal to m, the gradient, or the slope. Or I can tell you now we'll call the same thing dy by dx. So I'm finding the rate. So when I find dy by dx, I'm finding the slope. I'm finding the gradient. So in order to do this, I'm going to have, and in general, y is equal to x raised to the nth power. My dy by dx, my dy by dx is going to be equal to n, the power that is going to be used to multiply the coefficient of x. And then you're going to reduce the power by 1. So see this n here is this. And I'm reducing this by 1, see it here, so n minus 1. And that generally gives you the answer. Fair enough? Well, if you talk to me still, do you know?
Yes, sir.
Yes, sir.
All right, watch me now. So let me give you an example. We're going to go through this example again. Let me bigify it. That's technically it when you're doing little school stuff. When you reach big school stuff, no, you're not going to talk about y2 minus y1 over x2 minus x1. Nah, big school stuff, you don't know. Big school. I don't know if I told you, maybe I told the calculus students, but let me just say to the business calculus students or repeat myself. As a student asks a question, just now. Students, what I'm teaching you now is actually pure math, the pure math syllabus now. What we're learning now is on the pure math 1 syllabus. All right, and what I'm going to be moving into next tonight, it's also a pure math 1 topic. Big people something. This is not CXC anymore. CXC done when we reach year 3. All right, so let's go. You're given a function y in x. Y is in x, meaning the function y is defined in x. When I'm differentiating y, as the nomenclature told you just now, see it here, the nomenclature.
Sir, what
All right.
nomenclature mean?
Just the name. We just want someone bright tonight. Name. We just want someone bright tonight. Right? So they named. When they name something, so you have y. So when you find y, you're going to differentiate it. The notation for the differential of y is going to be dy by dx. The notation, the naming of y, when you differentiate it, you can get dy by dx. And what you're going to be looking for is the power as indicated up here so, and you're going to multiply by the coefficient of down here so, and then reduce the one power up here so, and then we end up with this beautiful looking something. All right? So x here is raised to the first power. So it's going to be 1 times 4 is 4, and I need to reduce the power by 1. So 1 minus 1 is equal to 0. But we can recall that anything raised to the power 0 is numero uno. Anything raised to the power 0 is numero uno. It's 1. So 1 times 4 is still equal to 4. Oh, come
Sir,
on. Yes, please.
so that's the answer for x to the power of 0.
What is 4x to the power 0 in its simplified form?
4, sir.
4. Because x to the 0 is 1. And remember, the differential of a constant is equal to 0 yesterday, today, and tomorrow. Every single time. When I differentiate and you know how to identify a constant. A constant is just going to be a number. An integer could be anything. Could be a rational number as well. When it stands up by itself, boom, rational. I mean, constant. -5 alone by itself, constant. +5 by itself, constant. 0, constant. All right? Watch me now. I don't need. Yes, you could. That's the answer. So the differential of that, of the question that I just gave, is this. The answer is 4. Your answer is 4. Now, yes, I agree that I did one question, and it may look a little far-fetched, but let us look at another example. What if I say y is equals to 3x minus 2? dy by dx is equals to what you think?
3x raised to 0 minus u.
Which is
3,
3,
sir. 3.
3.
3,
And when I differentiate the constant, I get what?
0.
0. So see, boom. And that's where I want to get it. You just write down the answer. You see the steps I'm going to show you up top there? Me no want to say none of them steps down about the book. I am only doing it because I'm teaching you the topic. So we're going to get to a stage where we can get the questions, and then we're going to differentiate by inspection. You're going to see something, I'm going to write it down. And we're going to differentiate like we're crazy. Because differentiation is really a mental something. It's mental mathematics. So very good. Now, that is the simple form. That is the simple form. Let me complicate it a bit. What if I say y is equals to 2x to the third power plus 5x squared plus 3x minus, say, 6. No, watch me. We are differentiating. Tell me, when I differentiate 2x cubed, what do I get?
2x
Sir,
squared.
2x squared.
Think about it. I'm differentiating 2x cubed, what do I get?
6x.
Sir, 6.
Oh,
Six
yeah.
X.
6x squared, right. I heard 12x squared. It's supposed to be 6x. Everybody seen the 6x now?
Yeah, 2
Okay.
times 3
Yes,
is 6.
sir.
When I differentiate 5x squared, what do I get?
10x, sir.
10x.
10x.
Very good. I love the sound of that. When I differentiate 3x, what do I get?
3
3.
plus 3.
Good. And if you never say it right, out of course, you know why? Because the number 2 question was similar to that. When I differentiate the minus 6, what I get?
0, sir.
0.
So that's my answer. And that's we can write the 0. That's my answer.
And just
Everybody
that's
say
it,
that?
sir.
And that's it. Done.
Yes, sir.
Alright,
All right.
so we wouldn't simplify it.
No, we no business them to differentiate it. We're not simplifying nothing. The simplification D is not coming just yet. The simplification is going to come in and move into the new topic, the second topic for the day. All right, watch me now. I'm going to ask us to calculate the second derivative of that function. So remember, in order for you to do the second derivative, you must calculate the first derivative first. You can't do the second derivative without first doing the first. All right, so everything is done sequentially. So when I differentiate dy by dx one more time to give me d squared y by dx squared, what do I get? 6x squared now becomes?
12x, sir.
12x, sir.
And 10x becomes?
10.
Plus 10.
Plus 10, sir.
And 3 becomes?
0. 0.
Good job. Excelente. All right. I'm going to find d cubed y by dx cubed. It means that do I differentiate the dy by dx to get the d cubed y by dx cubed? Which one do I differentiate in order to get d cubed y by dx cubed?
D
D squared.
B
D
square.
squared.
Very good, because I just said you have to do it sequentially. So if I differentiate dy by dx one more time, I'm going to get d squared y by dx squared. So in order for me to get d cubed y by dx cubed, I must differentiate d squared y by dx squared. All right? Now, when I differentiate 12x, what do I get?
12.
12, sir.
Well, that's 12, sir. Yeah.
And when I differentiate the 10, what do I get?
0.
Very nice. When I find d to the fourth y by dx to the fourth, what do I get?
0, sir.
I get 0, because this is a constant. Now, was that difficult?
No.
No, sir.
Is there anyone in the class, business calculus 1? Is there anyone in the class that don't feel comfortable with this just yet? I know calculus 1, for the most part, you are learning it. It's really not difficult. I gave you the rule. If you follow the rule, you should be good to go.
Sir,
Yes, sir.
could you differentiate just one of these figure 6x squared? Could you just run that through again from number 3?
What do you want me to do for you?
Differentiate 6x squared.
This one?
Yes, sir.
6 times 2 equals?
12.
2
Yes.
minus 1 equals
1.
that is 10 to the first power. 1 times 10 equals
10.
1 minus 1 equals
0.
and anything raised to the power 0 is so 1.
1.
And 1 times 10 is
10.
and the differential of a constant equals
Repeat.
the differential of a constant equals read that
0.
yes, I have nothing here.
Yeah.
Yeah, meaning I understand it now,
Okay.
sir, or
Yes, yes. I understand that.
okay. Good job.
Okay.
All right, I want you to start working on number 4 for me, please. I'm going to put a series of them. I just want to make sure that you are following.
So for each of these questions is only dy by dx we're finding.
For no, yeah,
Okay.
for no.
Sir, in exam, if they
Mhm.
ask us to find the second
Derivative.
differentiation, yeah, how will they ask that? Is it that they would put e to the power of 2y over d?
They just tell you. They will tell you, find the
Okay.
second derivative.
Rate name the right
Derivative,
one.
derivative,
So you can write
derivative.
it from up here.
Derivative. Derivative. It's not correct. You hear it. Second different. You'll see it, you know. You'll see the questions. I'll give it to you and I'll give you the spelling. Second derivative, second differentiation, differentiated twice. So everything that I just said a while ago, it is the same thing. So find the second derivative. Differentiate the function twice. Find d squared y by dx squared. Yeah, man. All of them, they mean the same something. Then if you find the differentiation one time and then go again groups and find it a second time. All right. So look at 4 and 5 for me, please. And number 6, I'm going to give you 5 minutes. I know some of you started. I'm giving you 5 minutes.
So you said the second, we should find the second derivative, right?
No, man. For this one here, okay, yes. Find the first and the second derivative for me. Find the first and the second derivative of 4, 5, and 6. That means I need to give you more than 5 minutes. 7 minutes.
Question I asked you earlier, and you said the first derivative we're finding.
I know, but because the question is asked again, I thought about it, but no, the question that, no, don't worry about it, Nigel. Mario just asked a question while we're gonna say, okay, what the heck, it won't kill you. Go ahead, and you see the space that I left before is just enough space to write the first derivative. But because Moya asked a question, I say, you know what, it's not gonna kill us. Let's just find the second derivative. All right? Thank you. Easy, Papa.
sir. So there.
Yeah, man, I have nowhere going. I'm giving you enough time. I'm looking at the responses in the chat. I'm not commenting though. I'm not commenting on those yet, but I'm
So
seeing
you can
from.
post it on the chat. Alright.
Yeah, man, you can post it on the chat. I'm seeing a few.
Where should I stop? At D2Y?
The second derivative, yes. The second derivative.
Okay.
Mhm. All right, 3 more minutes, guys.
Much more time we have, sir?
Half a minute.
I want to really have the time then. Okay, sir.
All right. Ready or not, here I come. You can't hide. All right. dy by dx equals?
$28 x square.
Q.
The
Cube.
three up the top, yeah. Q then call it, something like that. and
Minus
minus
16.
16x.
That's done?
That's the
Yes,
second.
sir.
Yes, sir. That finished.
What is
Right,
b
sorry.
squared? Go ahead, Levan.
84 x cubed minus 16.
84x square
Yes, square. The two.
minus 16.
Okay.
Okay, thank you. Question. Is there someone in the class that did not get that as the answer? Speak now, or you shall hold your peace forever. I'm happy for how this is going. But if you're having a difficulty, let me know. It's drawing very close to 7 o'clock.
Sir, you can differentiate further.
Yeah, but I don't want you to go further. It can.
Oh,
So
okay,
you're not going to go down until you get 0, you know. I am only showing you that you can. Your syllabus says that you need to go up to the second derivative. So I'm just showing you how you can get it.
So I get the 84.
You tell me. Put in your calculator. 28
Sir, 28
times
times
3
3.
until we get error. Put 28 times 3 in the calculator until what you get.
D square y. It's not that square used to the 28 times 2.
All right, you lost me.
All right, so
This square y is found by using this one.
Yeah, so I get the first part and I move on to d square y. What I did was I took the 2 from d square y and times by the 28.
What 2?
The
For the power.
d2, the power. No, it's not that me use, sir. I see where you're going now, but yet I use that too.
No.
I swear I went wrong, sir, but I just tell you what I did.
Okay, fair enough. So this is what we're using. Always the power times the coefficient of the variable there. So 3 times 28 is 84. And we'll always reduce this by 1. So it's going to be 2. That is left. That is to the first power. 16 times negative 16 times 1 is negative 16. Agreed?
Yes, sir.
dy by dx equals?
Then we have 6 raised to the power negative minus 1 raised to the power negative 3 over 4 minus 4.
Is she correct?
You can have 1x.
Same difference.
I sir, I have 6x.
Over 3.
I have 6x minus.
Sir, I don't understand this one.
Sir, would it be okay to put 6x 0 since it'll be the same thing?
6x to the 0?
Yes, sir. Given that even if it's a negative, it would still be equal to x raised to the 0.
No, sir.
So I can have 6x minus 1x minus 4. It's wrong?
Say it again?
6x minus 1x minus 4.
Yeah, it's wrong because I don't have the powers.
Oh, may I have the powers?
Sir, so like we have 1 raised to the power negative 3 over 4.
Say it again.
That's
Say it
right.
again, Chan.
Sir,
Say it
I
again,
have
Chan.
one. Sir, I see I have one X there, but I just have one. I want to know if that is fine.
You have to add the X.
Do I have to have one X?
Or just
Or
X
X
alone.
itself?
Mm-hmm.
Okay.
Sir, so the decimal is not acceptable.
Sir,
Yeah, man. I just want to answer that one more. Go ahead, Nigel.
I'm sure if you hear me, sir. That is the correct answer.
What is the correct answer?
No, man, ask if what you have there is the correct answer, sir.
Yes, sir.
So, sir, all the four, we get the four at the end.
So, sir, we must put in the 1x in the middle there, sir.
You notice the one is in a different color? Because I never had it before.
Oh, so that's the X. Okay.
One X or X. Nigel, coming back to you. Question. Nigel.
Sir.
All right. It's in Macaulay.
Yes, sir, I hear you.
Go ahead.
You had 12x to the half, right? And you said minus 1 from whatever power is there. But we have a half, sir.
What is 1 minus a half? Sorry. What is a half minus 1?
Negative a half.
See, try to listen.
All right, so see it? No. That's literally not what I did.
But you see it now, though.
So I'm going to convert the half to, tell me if I'm right or it can't do so, sir. So I'm going to convert the half to decimal. So I literally just chop 12x in a half. I'm going to have 6x. But I literally never write back the power.
You have to. You know, let me answer you now, Moyo. If you put 0.5, I don't have a problem. If you put 0.75, negative 0.75, I don't have a problem. Where I have a problem is when you come on to a different, a recurring decimal like 1/3 and just going to put 0.3. That don't make it. So that's why I say to students, generally, use your powers as fractions, not as decimals. Not as decimals. You know, I had promised the business calculus students something to show them something. I'm going to use it to explain this very concept, why we shouldn't do it. But I also want to say to you, sir, I have to write the negative a half, I couldn't just write 6x. Or, sir, I have to write the x to the second term, I couldn't just write 1 raised to the negative 3/4. The Angel.
Here, sir.
All right. I borrow $100 from you.
Not so much money, sir.
And you said to me, say, boy, sir, you have a thing upon you. I say, yeah, man, thanks, man. And I took out $100 Jamaican dollars and give to you. That's all right, don't?
You take out 100 Jamaican dollars and give back, sir? So you're a scammer.
So therefore, when you tell me, say, not just write back 6x, now go call on a scammer then. Because 6x raised to the negative a half cannot be the same thing as 6x alone. You're a scammer.
So your point, sir.
Yeah, man. So you have to make sure that you write back to something proper, because see, in another context, you're going to stone the man and call Pope on the man. So you can't do it like that. All right, next.
Sir, hold on.
Yes, please.
I don't understand. You said the 4x raised to the what that quarter? Where you have 1 there so in front of the x? Where the 4 go?
A quarter times 4 is?
I don't know. I don't have my calculator.
Well, write it up on paper.
Okay. All
Watch
right.
me. 1/4 times 4, which is the same thing as 4/1.
1.
Can you see that? Sure. You can stop writing.
Excuse me, sir. How you get after the -1x, I see you have -3/4. I still don't understand how you get the 3.
You know what's the problem, guys? Some of the foundational stuff still missing. Some of the foundational stuff, look at that one for me, please, but some of the foundational stuff are still missing. And you know, don't know if it happened to you before, but you know, well, let me find out. Has it ever happened to you where you here's the calculus 1 grade release and you put in the information check and then your heart skip a beat? It ever happened to you yet?
Put in your what, sir?
Yes.
The information for check?
Sir,
Yeah.
Naveen. Yeah.
When you put in the login and your heart just you check for your CXC results and you just get nervous at one point in time. A while ago my heart just almost skip a beat. I say, blow out.
So
We
you
can
are
move
the
on to the other
serious.
topic, you know, and the man them not gonna know that. Are you seeing this now, Mom? 1/4, 1/4 minus 1. The LCM is 4. 4 into 4 goes 1 time. And 1 times 1 is 1. And 1 into 4 goes 4 times, and 4 times minus 1 is -4. So I have 1 minus 4, which is -3, and that's -3/4.
Sir, the 4 that you minus it from is the 4 that's beside the x
No,
or the quarter.
neither. What's the LCM?
4.
How many times can this 4 go into this 4? 4 into 4?
1.
1 times this 1 equals? 1 times
There
1.
is 1.
How many times can this 1 go into this 4?
4.
What is 4 times -1?
-4.
What is 1 minus 4?
So, -3.
And I put my LCM.
Sir, I understand that, you know, but I was just going back to a question that you did and I tried, you know, put them together.
Mm-hmm. Don't do that to me. Don't. You're giving up, and that's not a part of my MO. So don't give up, and don't say don't know.
Sir, I can give you the question and you show
Sure.
me. All right. So it is
Waiting on you.
so yeah. All right. So it is 8 1 over x to the power of. Sir, let me
What?
say this now. Mr. We can write it. You can use your board.
Go ahead. Write it over the side though. No, erase that from board, no, miss.
There were to erase, realize me I had foolishness. Okay. That's it, sir.
Okay.
So you said when you reach over eraser, right? That's so the 9x to the third power. And this one we kind of get confused.
Is it to the third or to the 1/3?
1/3.
That's what you have?
Yes.
Okay. I will give the class a minute or two to all work that question before I do it.
We're going second derivative for that question as well, sir?
No.
Just first.
Yeah.
Okay.
Are you all finished now?
Yes, sir.
Is there anybody still working? Talk up now. Anybody working? All finished?
Sorry, but you can go ahead.
No, man. I want you to finish your question. I want you to finish your question. Hurry up, Mario. Hurry up. 1 more minute.
Yeah, you seeing the test?
Yes, I am.
Mm-hmm.
All right, guys. So, um, oh. Okay. So I'm seeing some responses in the chat, and some look good. Some of them I'm going to send back to the drawing board. But what I'm happy about is that we're getting somewhere. Let's go. Let's go, let's go, let's go. Oh. Okay. Business Cal. I don't know if you heard
Sir,
my phone
before
go
I
off.
start that, sir, we can point it to a different direction real quick, sir.
1 minute, please. Let me just make this announcement. Business Cal, I don't know if you heard my phone go off a while ago. Just at 6:44, got WhatsApp message. And I'll ask you to check for me on your business calculus registration based on what I'm seeing here. We'll try tomorrow. Wasn't that work to So at some point in time in the class, don't matter check now if we're gonna get distracted, you know. At some point in time, you check and then let me know. Because as promised, I'm still trying to do that. Error, to see if the course was selected.
Oh, yes, sir.
It was selected for you.
Sir, it was selected, sir.
Okay, fabulous. So is there anyone in the class, business calculus, is there anyone that their course was not selected?
Sir, I checked on mine today and it wasn't, but I'm going to check now.
All right, good job. Wesley, your turn.
Yes, sir. I'm going all the way back up to the top. That very first example. May I confuse myself? Because where you have 4x to the power 0 versus the recall where you have 5x to the power 0, but I get two different answers. Because they said the constants are equal to 0, but with the 4x to the power 0, I get back 4. Where am I going wrong? Or am I missing?
No, but remember, no. What I'm saying to you is that this 4, x, 1 minus 1 is equal to 0. And I'm saying to you, what I'm going to have really is x raised to the 0. Anything raised to the power 0 is 1. Anything raised to the power 0 is 1. So technically, when I don't have to write x to the 0 because x to the 0 is 1. So I can remove this and just simply write 4.
All right, get that, sir.
Come back
and
down
just
to what
by
now?
default, 5 constant is just equal to 0.
The differential of the constant is equal to 0. Once I have a constant and I'm differentiating it, it's going to be equal to 0.
So when you do the breakdown, that arrow that points down to 5x, isn't x to the power 0 1?
Right, but this yet I have not yet differentiated that. All right, I think I know where your confusion is. I'll come in. I'll come in. I'll come in.
Sir, while I do that, tell me why them people here delete all of my course system.
What they did to you?
None of the courses are there now. Everything.
Oh yeah. That's fine. So that was the second message. So that you remember you were already registered. So the business calculus could not be added. So we had to deregister you. So now that it's supposed to be added, she's saying that she'll ask them to put it on back for you tomorrow. So you don't have to worry about it. Once it's one, and it goes for calculus 1, if you are already registered and then you decide that you're going to do another course, when I'm trying to give the override, it tells me that student is already registered. So I have to call Students Finance for them to deregister you so I can add that new course. And then Students Finance will re-register you.
But
I'm sure. Go ahead.
I called them and they did their deregistration, and then I went to affairs and they selected the course and all the courses were there. So they wouldn't need to go through all of that because it was selected by Students Affairs. So all they did needed to do was
When
the
was that?
registration.
When was that?
The in this week when I spoke to you and you told me it was done. I think it was Tuesday. I know everything was removed.
Sir, it's the same for me. I'm not seeing my courses.
That's Kimayo?
Yes, sir. And it has been like that from Monday, I believe.
Kimayo, remember the last name, please.
Samuel.
Samuel.
But I realized that the courses are on campus, but not area.
Pen, you're Williams, Pen?
Yes, sir.
All right. So I just sent Students Finance a message I don't like doing this, but I keep messaging her way after school hours.
Sir, if them did answer them phone, you would have to do this. I don't know why them have phone.
Or even emails, sir. I sent my receipt from last week about the payment made, and I still haven't received a response. Additionally, I just wanted to verify, how do we check to see if we are registered for business calculus particular?
Well, your classmate, I forgot to answer that one day.
He is somebody.
All right.
Sir, I'm seeing my courses, but I'm not seeing business calculus. So I'm not sure if you're able to assist. Shauna Wito.
Let me add you to the thing. SHAUNAT.
Sir, is this just business?
Yeah, man. You guys are okay. The calculus one students are okay. It's just that they are doing what we call a block scheduling. So
right.
Time is running out. So the message just came in a while ago. So I just announced it. All
My
right.
question I ask, sir, is my status on Arian is still showing that I'm not registered.
Rockstone.
Not sure why.
All right. All right. I can ask her for you, Angel.
All right. So
Nice, sir. Alyssa here.
Yes,
I'm
Alyssa.
not doing it here, your course here on my thing as well on Arian to register for it.
All right, no problem. I'm adding you to. I just added Alyssa to this stuff. All right, let's get back though. So I
And
just added Shauna. And who?
Tiana Edwards.
All right.
Sir, that's one thing, sir. My course have already been selected. She just need to register me now.
All right, then cool.
Mm-hmm.
All right, let's get back. Let's get back. All right, so okay, so Nigel, talk to me.
Yes, sir.
All right. So what I'm going to do is put what I'm going to do is to put x to the 0. Come on, Mr. Shancho, what is wrong with you? I'm going to put the x to the 0 up here. So it's just that I didn't want, I was squinching it up right here. So, and then now what I'm going to do is to erase this so that it doesn't confuse you. Let it think that something else. So this 5x to the 0 is what it is that we're differentiating from up top here. So this is my function. And I'm now saying to you 0 times 5 is 0. So therefore, if I want, I can just put plus 0. Because when I multiply this 0, that 0 by this 5, I get that 0. So I don't even have to say x to the 0 minus 1. Because 0 times anything is 0. You follow me?
Yes, sir.
Yes, sir.
So this goes there. Sorry. I said Nigel. Wesley, it was you who asked the question. Where's the snipes? Yeah, man. Sorry.
Okay.
Yeah, but Wesley, well, Nigel, you say you see it. Wesley, you see it now, right?
Yes, I'm seeing it now, sir.
All right, good job. So the only reason Errol, that I did, I put it on here so is because I didn't want to squinch it up right here, so. But I see I eventually went and squinch it up.
All right, I understand, sir.
All right, good job. There's another question. Somebody is coming in. Okay. Go ahead. You're a little choppy, but go ahead.
There are things where I had the same issue as well until I identified it. It's where you have equals 4x over 0, but you mentioned that you're just showing us explicitly why
right.
why that's there.
Yes,
so
yes,
I think
yeah.
that would be the step today to remove that step where you have and put it below.
And put it below it, yeah. 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 All right. So let's continue now. So we're going to do this question. Kimaya put this question on, gave you an opportunity to do it. So dy by dx is going to be equals to a half times 8 is 4. I'm reducing that by 1. So 1, a half minus 1 is a negative a half, plus 1/3 times 9 is 3.
3x, sir.
And I'm reducing 1/3 by a half by 1. 1/3 minus 1, so I can get negative
Negative
2/3.
2/3.
And then a quarter times 4 is going to be 1, so that's negative x minus 3/4. Look at that and tell me if you agree. Did everybody get that, Kimaya?
Sir, no, I understand.
You understand it now, mommy?
Yes, sir.
I'm sure I agree, sir, but back to question 5, sir. I was asking, sir, how we get 4 at the end, minus 4 at the end,
sir? Wait, say what get the minus what?
The negative 4, sir. Since it's 4x, how get negative 4 at the end?
Sorry, he's saying how I get negative 4, but I don't have a negative 4.
Sir,
Sir, you
question
answer the
5, sir.
question.
The minus
Question
4.
up top.
Question
That
5, sir.
question.
Oh, brother, so you know, tell me, say, sir, move to the other question. You, you have me, I wonder a while ago we had talked about, I get this minus 4?
Yes, sir.
When I differentiate negative 4x.
Sir, man, mix it up with the constant. Like when you have the constant here, like it's 0.
That's right. But this is not a constant. See the variable right here,
so? My bad, sir.
Yeah, man. But keep the questions coming. No, man, I love it. Don't feel no way. I love the questions. Keep the questions coming because those questions make my life easier because it makes you understand a little bit more. And when you don't ask the questions, you are sitting on misconceptions, and those misconceptions will kill you. Sorry, I shouldn't use that word on Zoom.
Question, sir.
Go ahead, Papa.
So we know our big people, right?
Mm-hmm.
And but they kind of have the 1x to the negative 3/4. I wouldn't
For which
necessarily.
question, Papa? For which question?
For the same one, sir.
Number
Same
5?
I just do, yes, sir.
Mm-hmm.
But
wait, say you had x to the 0?
No, sir. I had, so you have that green one there.
Mm-hmm.
Yeah, I actually had that for mentally remember in case
And
we
that's
are doing
fine.
second derivative.
And that's fine. That's perfectly fine. Every now and again, I put my 1 there as my placeholder. So you're not alone. Perfectly fine. And it doesn't make you an adult or a kid when you're doing this stuff. It to this day, sometimes when I'm doing it, I put it there so that, and especially if I'm doing something to explain to somebody else. Yeah, man, that's perfectly fine, Pop. You get full marks for it. All right, let's go. I did ask for the second derivative, so let us do the second derivative for this one. Ha ha ha. D squared y by dx squared equals negative a half times 6 is
Negative 3x.
negative 3x to the negative 3x to the what?
Negative 1.5.
Which is negative 3/2. Me know what? Me know no problem, you know. You think I never know the problem before? Why you think I wrote this question? Why you think I gave the business calculus students this question? Me know. Me know the problem. Me know that I'm teaching before some of you were born. I know I said some. All right? Me know say this year was going to be problematic, and this was given. This go away from here, Penola. Go, go away and leave me alone. Sure. Next thing go start with Maya. Make sure go start troubling me. Sure. When I look right here, so, and incidentally, one of my beloved students of many moons, offspring, is in my class. All right, one of my beloved students, offspring, is in my class. I'm just saying, so I'm not old, I'm only 16. All right, let's continue. Maya, no comments, please. Maya, no comments. So I gave the business calculus students this question. And I said, on hold that, stickle that. It's all right.
But kind of understand it a little better now with the side work there.
Yeah.
So that's how I got it. We can't do it now. You can't trick me again.
So you think? Watch and see, man. Very nice. I'm happy.
Excuse me, sir.
Go right ahead, please, D.
I realize I have -3 over 2. Or you get the 2, you -3 from 1.
Which one are you talking about, number dearest?
The last
Oh,
one.
negative 3 over 2, yeah. No, hey, Kimmy. No, it is -1/2 minus 1. You remember, Kim? Remember, we're reducing it. We're reducing this, Kimmy. Look here. It's -1/2 minus 1.
Sir,
Yes, please.
can you do me a little favor? Can you
Go
hear
ahead,
me?
Logan. Go ahead, Logan.
Sir?
Go ahead.
Okay. Can you do the part 2 of it?
Which is part 2?
D2y and dx2.
Yeah, that's what I'm doing.
Oh.
That's what I'm doing.
And also D3.
Nah, we're not going to go to the
confused.
we're not going to go to the D3. But I'm doing the D2 now. I only stopped because of this -3 over 2. Remember, students, please. It is -1/2. Remember, I'm subtracting 1 from this -1/2. So -1/2 minus 1 is -3/2. Or, no, I'm not going to say or. I'm not going to do this stuff. All right. Do me a favor. Take out your calculators. And you can't tell me something on a calculator. Both groups are in a calculus class. Most of the calculator. Take out your calculator for me, please. And work with me. It's in the name. Ha ha ha. Take out your calculator and do me a favor. You're going to press -1, A, B, C, 2. Go through that for me, please. -1, A, B, C, 2, minus 1 equal -1, A, B, C, 2, then minus 1 equal. And you should see this. -3, one little something so, and 2. Let me know if that's what you're seeing.
No, sir.
No, sir.
Because, sir, may I see -1, a little something there, then 1, then a little something there again,
Oh,
and then 2.
Sir,
sorry.
no
Yeah.
answer that for me.
No. -3 over it's -3 over 2, but guess what? I said -3 that over 2. That's when it's press the shift button. So you're going to say -1, the little something, then you're going to say 1 again, the little something, and you're going to say 2.
Yes, sir. That makes sense.
Sir, when you say ABC something,
To the left side, left-hand side.
ABS?
No. A, B, /C. And if you
Still
calculate it,
looking, sir.
And if the calculator don't have it, throw it out.
Sir, what we forget?
-1/1/2.
One again. Where so we must put on the calculator?
Let's go with the algorithm again. Let's go. It's going to be -1 ABC 2 -1. Then press equal. And for the answer, you're supposed to see -1, and look at something there, then another one, then look at something there, then another one, then it's going to say 2. And when you have this answer, and you press second function or shift, you'll see -3, then look at something there, and 2. Try that for me, please.
Sir, is it the A B over C?
Yes, ma'am.
The first something that I put it with is -1 ABC 2 -1. The first when we get for that was -1, the look of function thingy, look of arrow something, and then 1, the look of something again, and then 2 and a 3 1 we get.
Sir, Sir,
No, some of you, like in the chat, I'm seeing one of the good type calculators. When you look at it, that's a natural display calculator. When you look at it, you can see a fraction that is under the ABS sign. That is their fractional key. So if you put -1 up there in the numerator, and then use a blue trackball in the middle of the calculator and put the 2 down the denominator, you have to come out of the fraction now by using the right button on that. And then you put a -1, and then the answer going to give you -3/2. Try that for me, please. Give me half a second, please. I'm muting for half a second.
Sir, I'm not getting nothing on my press shift, you know.
I don't know going for me either. I know you alone.
All right, I soon come to you guys.
So work it out manually, because my calculator understand your language.
Nigel, I mean the calculator can't do it.
Sir, I was supposed to put in the calculator.
Sir, I'm not get what you just said, sir.
All right, okay. Boy, I'm telling you, it's a uno.
Money I forgot learn it and you something, sir.
All right, come. And I want you to get it because, as I said before, while I'm teaching you directly, I mean, not directly, that's not the word I'm looking for. I'm intentionally teaching you how to use the calculator. Intentionally. Now, this is separate and aside. Is one request that I have of you. One request. Is so how I'm patient with you. Anybody think that I'm being patient? If you think that I'm not being patient, you can say no, I don't feel no way. Anybody at all, even one person think that I'm being patient? Okay, three somebody say yes, I'm being patient. All right, good.
Good, sir. Good.
So hear what? You see, anyhow, you have my niece and my nephew, aka your daughter and your son, and you rough them up, and me here are trouble. I want you to be as patient with them as your teacher has been patient with you. All right? Just like how you're not seeing one something and just make it everything, just throw off everything. When they are learning and them not seeing one something, and sometimes the teacher them not recognize them now, see one something and say, oh, she's a slow learner, or he's a slow learner, or them, I don't like that D word. Teacher pick them and them will learn. No, when you teach, this is the final part of it, When the teacher teach, you must learn. So I'm saying to you, come, we're going to read one more time. We're wiping the slate clean. Wiping the slate clean. Let's go. Maya, go drink a cup of tea, Sure. All right. Let's go. And oh no, it's when Dijon talks, it's she talk dainty and D confused. All right, let me unravel it. Let's go. On the calculator, we're trying to evaluate 1/2 minus 1. Algorithm is going to be -1 ABC 2 minus 1. Chev isn't 1/2 the same thing as 1/2. Yeah, always. But you see, what I'm not doing now, Chev, is that I will explain it that way if I were teaching you, showing you how to do it manually. But now that I'm doing it on a calculator, I have to show you a different way. But sure, that is correct. Now, let's go. When you press equal now, your calculator should show you -1, one little something, so then 1, then one another little something, then 2. What it is saying is this here is being translated now as -1 and 1/2. That's what it is as a mixed number. All right. So that's what the calculator is going to do. If you have a natural display calculator, like the one Jay just put in the chat, you're going to have something like that. How do you do it? You press that button first, which is one method. Then you're going to press -1. You're going to use a trackball. Have the 4 arrows. And you're going to go down, press the down arrow. Then you press 2. Then you're going to go to the trackball. And then press the arrow that go to the right to take it from outside of the fraction. Then again press -1. Then again press equal. That may give you as -3/2, or it may give you as -1 and 1/2. Jay, try that for me, please, and tell me what you get. The rest of you to other calculators, try that for me, please, and tell me what you get.
Negative 3/2, sir.
Good job. Which calculator have Ferron?
Casio.
Casio who?
Casio. Casio was the second edition, Messi, right there.
No, man. In the number to the top right hand corner. 82 something? Or 115?
FX82 ES Plus.
Okay, ES Plus. Okay. 82 ES Plus. All right. Anybody else?
Sir, well. Sir, no, sit down. Yes, sir.
Go on for me, sir.
No, still. All right, hold on there. Who is this? Is this Sheva? Who is this talking to me now? Not Nigel. Who is this talking to me?
Me, sir.
Oh, Mario. Okay, Mario. Go ahead again, Mario. What are you saying?
Oh, sir, we never sit down. That's okay, sir. That's in the sir.
What calculator you have?
Yes, sir.
Huh?
Casio, sir.
Casio who?
FX82 MS.
Okay, so that's a deep blue calculator.
Yes, sir.
And you have the trackball in the center of it too, right?
Yes, sir.
Good job. And you have the ABC button to the top top left hand corner, right? Under the second function button or the shift button, right?
Yes, sir.
Good. So I'm going to say something to you and you'll follow me exactly. Those of you who have a similar calculator, work it and twerk it same way. I want you to turn your calculator off for me, please. D, I want you to try the same thing too. I don't want you to be confused. Moya, you okay?
I got it.
You got it now? Very nice, D. Moya, you all right? All right, Moya, go and sleep. Okay, Mario, let's go. The rest of you who have it, okay, see that, Moya? The rest of you who have it, let us go with it. Turn your calculators off, then turn them back on. Why I just did that, I want you to clear the memory from the calculator. Sometimes we just grab our calculators and start working, and then we don't recognize that something is stored in there.
Sir.
I will get wrong answer. Yes, please.
I don't know what to press after -1, the sign
It's all right. I'm gonna go through that. Which type of calculator you have, pen?
the real one. My name Delhi.
Excuse me?
Delhi, DELI.
I'm Mr. Chinsella calculator there.
Sir, no break.
Pen.
Man, they have someone named Delhi.
Pen.
No, shame I kill me. I gotta sit down.
No. Our pen.
Sir, I saw this here, sir.
Pen.
Can't tell me.
All right, Pen. That was a good laugh. You know, that's when you laugh, you release bully stress. I just relieve a bully. But girl, guess what? The one that Mr. Chin selling out. Open the back of it, Pen, and tell me if it use one big long battery, you know, like the AA battery.
Sir, you cannot tell me at my calculator. You're out order. You know what?
Relax yourself. Sure. All right, come now. Now that we laugh for your pen. Tell me if you see the ABC button at the top left-hand corner, my love. You know, that's so we live, right?
On my calculator. Everything is on my calculator. Just tell me if I press after me enter the function. That's all I want.
Pen. Make it sound like you make so.
First of all, right now I know say all my calculator. Year and a year. So just tell me if I press.
Liar till.
But I ask you.
Oh goodness, Pen, trust me. You know, if we go call Candice and Gerda one year. All right, let's go. All right, so press -1 for me, please. Ay. I mean, yeah, full of water. -1. And then now, you're going to press the ABC button.
But say me do all of that already, sir. Just tell me
Okay, all
what to
right.
do after.
And then press 2, pen.
Yes.
And then press the minus sign and then press 1 after that.
One me get.
And then press Deli now go on good. Press equal. Press equal and tell me what you get.
But says one me get, sir.
Sir, I
No.
-1.
All right. Pen? No. All fun and joke aside, pen. Seriously, no. But I'm going to ask you to turn the calculator off and I'm going to ask you to turn it back on. And then if when you do the something again and you don't get it, me no want use it. Back go give me such in.
Sir, I'm not do this today,
No, you know, my love is still up pen. All right, let's go. No, but seriously though, I want you to clear the calculator again because it means that some function is not recognizing the algorithm. So turn it off, turn it on for me. And then no, press -1.
-1 ABC
ABC.
AB/C.
Good. Then
Number
2.
2
Mm-hmm.
-1
Mm-hmm.
equal.
Mm-hmm.
I have -1, one function, one function, 2.
Then goods. Hold on there. And this matter I say forget to. So it worked then. The daily work. See that we see I go get
Yes, so what
-1.
do after that forget the 3, -3/2.
Press second function. And then press oh Lord, hear this now. Are you seeing F to D or are you seeing
Sir,
S?
everything there on my calculator.
No, it's one of the two. So you have to tell me which one you see. You seeing F to D or S to D? Look
Hold
in the
on.
middle. Look above like 9 or 8. The top number them. Look and see if it's S to D or F to D. Mm-hmm.
Hold on. It didn't but me not see it yet. S to D.
Sir, you have a sponsor. You have a
Hey,
sponsor saying
hey.
access instrument.
Hey. Hold on. Tell me which line it's in, cause me shame it tonight.
All right, then good. All right. So let me ask somebody else. Anybody has a calculator that has S to D or F to D? Just tell me what function it's above. What function on the calculator is above it? S to D or F to D?
Sir, the S to D have A, B over C.
So D over C.
D over C.
Okay. All right. Pen, try this for me now then. When you get the -1, the little funny sign, the 1 and the funny sign and the 2, press second function and press back ABC for me and tell me what you get.
What's the second function?
Shift. Top left-hand corner could be the first button.
Shift and then
And press by the ABC button now.
-3 and the ugly something and 2.
Boy,
So me have to go through all of this? Sir, don't cry it yourself.
Delia, go on. Delia, go on. Yes, so that's why you get it. So you have to go press, in order to get it as a mixed number now, you have to press shift to get back the mixed number.
So I can't can't I just do the one the number -1?
You have a deli. No.
I
Sir?
want to do that. That's easier.
Okay, sir.
Yes, D.
So are we when we press the shift and then the ABC again, are we supposed to be seeing -3, 1/2?
You're supposed to be seeing -3 over
Yeah.
2.
I'm
Not
seeing
1/2.
I'm seeing -3, the sign 1.
And then a 2.
And then 2.
Right. So you'll see this. Negative. You'll see -3, the little funny sign, and then 2. That's what it's in D?
No, sir, I'm seeing 1 and then 2. So I'm seeing the -3, the funny sign 1, the funny sign, and then 2.
No, man. What kind of calculator you have?
I have Casio.
A who?
There's another Delhi, sir.
No,
Hey,
no,
you see
stop.
you what? You
It's
see you
not.
what?
It's not. Okay, it's not. It's
Okay.
Casio. It's the
So D Johnny, it would have be bad if you have a deli?
Oh, I don't even know what a deli is.
You know what?
It's not it's the Casio FX82 MS.
The FS82 MS. Do you have I call it back in a class here. Do you have the Casio FX82? Yeah, man, the 82. You have the ABC button on yours, right, D?
Yes, sir.
Right. But I'm a little worried though.
Alright.
I'm a little worried that you're saying that you see -3, the little division button at the bottom, and then you see no, sorry, you're saying that you're seeing 1 and
Yeah.
-3.
1 and then the 2.
Sir, which branch you have?
She has a Casio. No man, she all right, man. She have a Casio. Do me a favor, D. Clear it for me, please.
Turn it off.
Turn it off and turn it off. Clear the memory and turn it back on.
Okay.
All right, let's go again now. -1,
-1.
ABC2, -1, equal.
Okay. I'm seeing the -1, the funny sign 1, the funny sign 2.
Great. Shift or second function and press by the ABC and tell me what you get now.
Yes. Oh, I have it now.
All
The
right.
-3 over
Yeah, man.
2.
So there was something else on the calculator. So let me just say something to you. I want all of you to get into the habit. Sorry. There are times I'm using my calculator, students, and I am pressing the clear button like a million times because sometimes when you press the calculator, you have some memory stored in the calculator, and it's going to push out an incorrect answer. So just get into the habit. Once it is that you're using the calculator, just pick it up and then sorry, pick it up and then clear it before you start using it. All right, now that we're okay with that one, and this was side work. Oh, come on, Sir Shandy. Boy, trust me, I laugh too much, man. Boy, trust me. Pit make me laugh a while ago, man. This is side work. All right, so let us finish off this question, please. And then now, what we're going to do is we're going to multiply that -1. So, what was it, no, Lord? Nigel, I think you said it. You said to me that, sir, say, big man thing, but, so I put my -1 there. Don't have a problem. Because, see, when I help you now to do the second derivative, when you multiply -3/4 by a -1, what do you get? Hello? When you do this, that -3/4 times 1, -1, what you get?
Sir, positive 3/4.
Yeah, man, +3/4. +3/4, x. Watch this now. I have Chevy said something earlier, and I'm gonna show you because I just used it a while ago in order to get my answer. And I'm gonna use it and I'm gonna write -7/4. Did anybody get -7/4?
Yes, sir.
All right. So what I want you to do for me, in order to try for that -7/4, I want you all to do -3/4 -1. I show you how to do that on a calculator a while ago. Negative 3 over 4 minus 1, and tell me what you get, please. Quick and fast. Negative 3 over 4 minus 1. I'm doing that
Negative
because
1 and 3 over 4.
second function, ABC.
Negative 7 over 4.
Good job. So that's why you can move very quickly with your calculator now. When you go into the multiple choice and then give them like a fraction, something there, use the calculator and evaluate the fraction. You're working against time and you can carry calculator in the exam. So use it. All right? Okay. I did my work right there. So R of X is going to be, all right, let's just do R of X quickly. R dash of X is going to be equal to 3 9 is 27, 27x squared plus 3 times 13 is 26, and a X minus 11. Is that okay?
Yes, sir.
Yes,
Looks
sir.
about right, sir.
Good job.
Yeah.
And R double X 27 times 2 is 54. That's 54x plus 26. Am I good?
Looks about right, sir.
Yes, sir.
Good. So that's what I'm saying to you. What we're doing here, guys, is just it's just looking at it and us evaluating it. Just looking at it and evaluating. All right. The truth is, there are many more differentiation that I can give you, and I'm going to give you. I want you now to take a 3 minutes break. Stretch, go to the restroom, bathroom, drink some water. I'm gonna move from this position to go and source a question that I am going to. How do I do this? Aha. I'm gonna source a question. I'm gonna screenshot it. No, I'm gonna do the question, but if I don't finish the question, I'm gonna screenshot the question and send to you because I want you to have this over the weekend. I want you to have this over the weekend so you can play around with it. So I'm giving you 3 minutes. No longer 3 minutes, 2 minutes now. Quick and fast. You're good, man. Where's the snipes? All right, my students. Your teacher is here, back with you. All right, so I was responding to some messages. No, I want you to stay focused. Don't let this negative business and fraction business get at you. And that's why I'm not showing you the actual calculation, the manual calculation. I took time out a while ago and show you how to do it on a calculator. Right? So if the question comes like that, you just math it out. Don't be daunted by it. Trust me. And remember, your teacher is here too. That has your back. All right. Now, I have all right, I'm gonna share. I'm gonna have that conversation with you. And then I'm gonna share stop share. And then I could have just a new share, but never mind. Share screen. What am I sharing? Mm. All right, so start broadcast. So I'm gonna share. Let me know if you're seeing my screen.
Yes, sir.
All right. I want us to focus on this now. All right. I want us to focus on this. These are some stuff that I wrote, so that I can get you guys to understand what is happening. Now, it says application to differentiation. Normally, I would do this much later for the Calculus 1 students. But because I'm killing two birds with one stone, I am bringing, well, normally when I'm doing the business calculus as well, I carry this down a little later on. But because of the nature of when the exam is going to be earlier on than usual, I'm bringing it forward. I'm going to read through this document with you.
When you say exam, you have to mid-semester and final exam.
Final exam. All right. So I'm going to read through this document with you, and I want you to work with me. So, we're talking about stationary points of single variable functions, and this is applications to differentiation. All right. We're looking at stationary points, single variable function. For Calculus 2, your lecturer, whoever is going to be your lecturer for Calculus 2, will go with stationary points with multi-variable functions. So with the single variable function, we're just going to talk about x. But the multivariable function, we're going to have both x and y. So I'm saying to you, note that similar to what I did here, that f of x is equals to y. The first derivative, if I give you f, it's going to be f dash of x. If I give it as y, it's going to be dy by dx, the first derivative. Who was it? No. Kimaya, was it you, my love? Kimaya, what it's not Kimaya, no. Somebody was asking about derivative. See it right there, so. So the first derivative, let me bigify it. The first derivative, if I'm writing a function in f, it's going to be f dash of x. If I'm writing it in y, dy by dx, it's just going to be dy by dx. The second derivative is going to be f double dash of x, or d squared y by dx squared. So for the single variable function of the stationary point, You're going to differentiate the function. See here, you're going to differentiate the function. That's why I had to teach you how to differentiate. And now I know you know how to differentiate. I'm going to differentiate the function f of x. I am going to set the differential equals to 0. That is, f dash of x is going to be equals to 0. F dash of x is going to be equals to 0. And what I'm going to do then is to solve for the unknown. I'm going to solve for the unknown. You're going to get a trinomial. Trust me. When I say solve for the unknown, you are going to get a trinomial. And that is going to be my second headache for the class. But you're going to get a trinomial. You have to factorize that trinomial. And then it's going to give you some critical values. It's going to give you some critical values. Critical values or stationary points or, yeah, turning points. I was trying to remember the other one. So I have stationary points, but sometimes they call it critical points. And sometimes they call them turning points. Right? So if you hear me using it interchangeably, you know exactly what I'm talking about. Stationary point, turning point, critical point. And then we're going to substitute our critical values. Remember, they are called values, not points. They are called values. Those are called values.
Because we haven't found the minimum and maximum yet.
Okay. And then now you're going to calculate you're going to put those critical values into the original function from up here, so. And then together, those are going to call the state. So actually, I see them, I have it written, I've never seen. Critical point, stationary point, turning point. Them all mean the same thing. And you're going to write them in the coordinate form as x comma y. As x comma y. So that's all that we're going to be doing. That's all that we are going to be doing. All right. So I am going to go now.
Sir, will you be sending that document to us?
Excuse me? You want that? You want my document?
The one that you showed a while ago, will you be sending it to us?
I won't send you the full document, but I mean I can send you that page with the rules there, how the step by step stuff.
Yes, sir. Yeah.
Yeah. So for the calculus 1 students, that was what the instruction that I want you to do. At the end of each topic, I want you to write a summary statement. I do this first, then I do that next, then I do this then. So when you know what it is that you're supposed to be doing, it makes the questions easier for you to answer. All right, let's go. So I'm going to give you a typical question. But I'm going to give the question that is soon. I'm going to give you the question that is pretty simple. I did say that I was gonna. Hold on, guys. I need to be true to my words. I did say that I was gonna Moya sent you an email a while ago. Can you let me know if you get it, please? And then I'm gonna
I'm checking.
thank you.
Sir,
Yes, please.
I see it. What do you want me to do?
All right. I want you to screenshot it for me, please, and I'm gonna give you access. to add it to, go ahead and add it to the document here for me, please. That's a question. I don't want to be writing the question. Good job. It's fine there if you.
I mean, I still put it there after it here.
Oh, that's where you put it. Okay, that's fine.
Yeah.
It's fine. It's fine there. It's fine there. Appreciate it. All right. Thank you, my dear. All right. So let's go, and we will end the class at this point. I mean, at the point of completing this question. All right. Now, the question says, given that the function y is equal to x squared minus 6x plus 1, we need to evaluate the critical point. Point or points? I'm going to call it CP. No. The first thing that you're going to be doing and I want you to listen to me carefully. The first thing that you're going to be doing is to write your function. And then you're going to differentiate it. The first something you do when you get a question on is, or you know, it says it's when it's a critical point, maximum and minimum, you know, say a stationary point question we're talking about. All right. The first thing we're doing is to differentiate. Tell me, dy by dx is equals to what?
X minus 6.
Go again?
2x.
2x minus 6.
2x minus 6. Very good. 2x minus 6. Excellent. 2x minus 6 is correct. Then we're going to let dy by dx equals 0. So I'm going to say that is 2x minus 6 is equals to 0. 2x is equals to 6. Divide both sides by 2. X is equals to 3. I'm going to put x equals 3 into y, the original function. Anywhere in the original function, I see x, I am putting 3. So it now becomes y is equals to 3 squared minus 6
times 3 plus 1.
Plus 1. 3 squares equal?
9. So it will be 9 minus 19.
No, sir. 6 3s.
6 3 is 18 plus 1.
It's minus 18, sir, not a positive 18.
So wait, what to the plus 1?
So it's negative 8, sir?
Negative 18. Sorry, negative 8 is correct. All right, my pen is not writing. So here, so it's negative 8. So my critical point is going to be 3, comma, negative 8. You see, I write as a coordinate form. That's what my critical point is. It's my critical point. It's a point or points, but I only get one. So this one is going to be my critical point. My critical point is going to be 3, comma, -8. I have to write it like that in coordinate form. The x value is written first, followed by the y value. So it's 3, comma, -8. Any questions so far?
Yes, sir. Why you put, all right, I'm seeing the 3 in the bracket, but why you put 2? Where the 2 come from?
Which 2?
In the question, y
Y
equal x
equals
squared.
3 to the
Look at
power
the
of
question.
2.
What is this saying?
Oh,
Yeah, man. So you see, I put it in y. That y is the same y
okay.
as this y. So I'm substituting in the original function. So anywhere in the original function I see x, I'm going to put in a number there in order to get y. Always get that into, always put that into practice. Fair enough?
Yes.
Is everyone seeing this so far?
Yes, sir.
Yes, sir.
Okay,
Yes,
okay,
sir.
nice job, nice job. I love it, love this one. If you have problems, of course, you can't stop me because that's what I'm here for. Now it says the coordinates of the y-intercept. The coordinates of the y-intercept. Oh, come on, Penny. It's a Friday evening. Don't do this to me, man. Sure. Watch me now. When I want to find the y-intercept, sorry, let me not answer that way. How do I find the y-intercept? Hmm?
So there's a formula for it, right?
No, man. It's just something if you tell me.
Well, you said the y-intercept, right?
Yeah.
The function before you even do that, you have to ensure that the function is equal to 0 before you start the figures. So whatever value y is, the x coordinate has to be 0.
All right. So the first part of what it said was incorrect, but the last part is correct. So in order to, the coordinates of the y-intercept is found when x equals 0. Always remember that, students. The coordinates of the y, I find the y-intercept when x equals 0. How do I find the x-intercept?
When y is equal to 0.
When y equals 0, right. So let me go back to one more time. Because you see, this is the second step in doing the calculation. The y-intercept is found when the other one equals 0. So if they ask for the y-intercept, that means x equals 0. If they ask for the x-intercept, that means y equals 0. Does that make sense?
Yes.
Sir.
I'm going to say it one more time because there's somebody in the class that don't understand it and don't want to talk. So hear me. To find the y-intercept, x is going to be equal to 0. To find the x-intercept, y is going to be equal to 0. Please note, when I'm finding the y-intercept, y is not equal to 0. It has to be the opposite one. And when I'm finding the x-intercept, x not equal to 0 is the opposite one that I'm using. So therefore, y is equal to x squared minus 6x plus 1. Y is equal to 0 squared minus 6 times 0 plus 1. Y is equal to 1. Question asks the coordinates. So the coordinates would be x is always written first, 0, 1. 0, 1. You write the x first, and we just calculate y to be equals to 1. Everybody seen that?
Yes, sir.
Yes, sir.
All right. Part 3 now says determine if the critical point is a maximum or a minimum. In that case, we normally call it the nature of the critical points. We need to find out how this critical point is behaving. Is it a positive? Is it a negative? And we just need to find out what is happening to it. So, in order to do the nature of the critical point, I'm going to recall this. Recall dy by dx is equals to 2x minus 6. Therefore, we now need to find d squared y by dx squared. What is d squared y by dx squared?
Sir, what is that? Nature of what?
2. What is CP? Sir? What is CP?
Oh, the critical point. Nature of the critical point.
Good job. Good job.
Sir, it don't look like CP. That look like one symbol. So write it properly.
Again, thanks, but it's for no calculus too.
No, sir.
Me say again, thanks, somebody else for no calculus too. Me now go through no more Friday even like this with Uno. Crazy. No deal. Hey, Pen, you good Pen? Pen, always Delhi.
Sir, avoid me, please.
Hey, what's that about
Goodness. Pen, I tell you, man, trust me. Hey, Pen, you have to come on campus, come meet me in a Pen. Yeah, I forgot me to teach a Pen. Real talk. Pen can't write me off crazy. Pen and me related, man. All right, come, let's go. So we need to find the nature of the critical point.
Is that
yes, please.
Error, sir, or that's dx squared?
Where?
The last equation, right? dxy, d squared y over dx.
Over dx squared. And I say it right.
No.
I say it right, man, but I merit it better because so it's going to be d squared y over dx squared, and that is equals to 2. See better, Errol?
Hold on.
Yes? No? Talk to me. You need to move.
Yeah,
all right.
Okay, sir. Yes, sir.
Okay, cool. Okay, so this is what is going to happen now. So the nature of the critical point is going to be, we're going to use the nature of the critical point. So when we differentiate the critical point a second time, if it is positive, it's going to be a minimum. M-I-N-I-M-U-M. And if it is negative, it's going to be a maximum. But what is this value here? Is that a positive value or a negative value?
Positive.
Positive. So it's going to be a maximum. No, I'm going to come back to this one because this one is based on what I did with you, I selected an easy question. When I say easy question, a question where the original question is a binomial, right? It's a binomial, right? But when you get these questions on the exam, it's going to be to the third power, always to the third power. When it's a binomial, the highest power is 2. It's a quadratic equation, or it's quadratic, and quadratic because it has 2. quadratic because it has 2. When you go to the actual questions that you'll get on the exam for this is going to be something that is going to be cubic. But I didn't do the cubic one because I don't want to introduce it to that just yet. My aim is to introduce it to the quadratic one first, and then we do the cubic one after. So if you can go through this for the weekend calculus 1, go through this for the weekend calculus 1, it should be good to go. I am meeting the business calculus tomorrow at 9 again. I don't have a funeral tomorrow. So calculus 1, please feel free if you can join. I know last week it would have been beneficial to the 1 or 2 students who joined. You join tomorrow.
Last week, sir. You
Huh?
send the link. Come and wait for the link in our WhatsApp group and it reach late, sir.
I know.
Come in.
No, let me tell you what happened. So last week, it's because my course is added to, well, I thought my course was added to Arion. It wasn't added to Arion, it was only added to Canvas. So because I saw it on, not Canvas, on Cellcat. So because I saw my timetable with the business statistics on, business calculus on, I thought the link would have come automatically. But it's not until this week when I went to add my business calculus students, I recognized that I am seeing it on Cellcat, but it wasn't added to Arion. So which is why they weren't seeing the course to add. So which is why earlier in the class, I told them that, yo, the course I'm add up, because I only learned that. So when I was waiting at 9 o'clock, when I tried logging on to the class, I couldn't get on. I couldn't get on at all. And then I had to I was going to use my personal Zoom, but it said that it was going to start at 9:45, I believe it was, or something like so. So when it came on, I was able to send it off to Kimberly and ask her to just disseminate it to the class for me. So last week was an anomaly. And as a matter of fact, it wasn't my class alone. There were 2 other classes going on that they had a similar issue with the stuff. But for sure, let me just look at it now because it's supposed to be sorted out.
Yes, sir. The link is there.
The link is there, great. Because it is not added to Arion. So for sure, do me a favor now, please. Oh, but you don't have to do me a favor, sorry, because all of you would have access to the stuff. So you can go ahead and just look at it and tell me, yes, I'm seeing it on a Saturday. It says 9 to 1. Good. So the business calculus is there now. It says fast tracked. It's not really a fast track, but them call it fast track. So you should see the link there now. So I don't have to send a link for tomorrow. So class begins at 9 tomorrow. All right, let me just finish off this and then this piece here, and then we call it. Oh, I did finish it. I did say to you that it's a maximum. All right, so here it's a maximum.
Sir, this is number 3.
That's number 3.
It finished?
Yeah. Somebody saying, yeah, it's finished. Yes. Somebody is saying, sir.
Sir, you have positive minimum there and then negative maximum, but you're saying positive. This positive number is maximum.
I said maximum a while ago?
Yeah.
I just said that to see if you're paying attention. Thanks.
Sir, all right,
You're
right.
Thanks for paying
Yes,
attention.
right.
Thanks for paying attention. Good. I love when my students pay attention. So yes, it's supposed to be a minimum. And what I'll end with is to say that a minimum, I'll end with saying that a minimum curve looks like this. Minimum. And I say to you that a maximum curve looks like that. And guess what? A maximum, yes, please.
So when it's positive, it's not maximum?
No. And that's what I mean. No, I just said that to see if you're paying attention. So now that you're paying attention, let me just say the right thing now. So look here. When it's maximum, it's negative. How do you spell negative again? What's the first letter in negative? Huh?
N, sir.
N, sir.
Right. Don't this curve for the maximum look like on N. Don't this look like on N. See, yes, no?
You can? Yes, sir.
Yeah, man.
Yes, sir.
So this
I
look like
see, man.
this look like one N. So that's negative. Anytime you see the N graph, is negative. The U graph is positive. All right. So the shape of this curve, they ask you to sketch the shape of this curve. It says sketch the graph of Y showing all the points. Actually, I wasn't going to do this until tomorrow, but let me just finish it up because I know some of you will not come to sketch the graph. I have a turning point of 3, -8. I have a turning point of 3, -8. 2, 4, 6, 8. -8, -6, -4, -2, 0. 1, 2, 3. It's as a sketch. Sketch. 3, -8. Boom, 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 boom. Boom, 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 boom. Right here. So that's my turning point. All right. And then the y-intercept is going to be 0, 1. 0, 2. This is 2. Right. So I can tell you my graph looks so. I don't know where it passes on the x-axis here, so I won't connect it. But if you don't see the sketch of this, you don't have to worry. I'll go back through this again next class. I'm going to end right there. We did well. It's getting progressively harder as we go, but it's not impossible. It's a lot, but it's not impossible. Now, what I want you to do for me, please, students, and especially those of the business calculus students, this is what I want you to do for me. After class, and you get a light snack, you're going to go to your bed. You're going to go to your bed, and you're going to try and get up. It's a Saturday morning, yes, and some of you may be working, but you're going to try and get up early and see if you can do a little revision lessons. Word. And then you can try and do a little bit of revision before class tomorrow, so that when we come to class, we are fully ready. Business calculus 1, please. I'm going to invite you to come out tomorrow. It's just some extra work for you, and I'm trying to give you as much extra work as I possibly can. All right? That's it for me.
Sir, is it 9 a.m.?
Yes, my lovey.
All right, sir. Good night.
Thank you,
So where's the
Mario. Good night.
coursework?
You will get it, man. I have it. Not the coursework. Classwork. It's not the
Where
coursework.
is the graded work then?
All right, I have it. I'll drop it off. It's
All right, keep it then, sir. Keep it.
Penola,
You
I love you too.
gotta do it.
Penola, I
Do it
love
for
you
me
too.
and grade it. Do it for
Penola,
me
I
and
love
grade
you
it.
too. Have a wonderful rest of the night, Penola. See you tomorrow,
Sir, I'm
Pen.
not understanding for.
Say it again, TT.
I'm not understanding for
Don't
the
worry about
graph.
it. Don't worry about it. Look through 1, 2, 3 for me for tomorrow, and then 4 we're gonna go back over that. All right,
Sir,
mommy?
I don't think I'm going to be in
Well,
class.
don't worry about it. We'll send a recording for you.
All right.
Yeah, man. Big up yourself.